folks, welcome to another video here. This is going to go along with section 7.1, deals with radicals. At first I want to lay the groundwork. Chapter 7 in general is going to talk about powers, roots, and radicals. Eventually we want to get to a point where we can solve an equation like this, which quite frankly looks a little nasty, and it kind of is. But we're not going to deal with this at all today. We're actually going to just look at the basics here, and then way down the road, 2, maybe 3 weeks away, we'll actually be able to solve something that's like this after some practice. So today we're going to look at nth roots and rational exponents, and our objective is going to be to evaluate nth roots using both radical and rational exponent notation, and we'll take a look really what that means. We'll start off right there with what that notation difference is. So first of all, I want to say that our basic definition of what an nth root is if we can raise the number to the nth power and we get another number, then we say b is the nth root of a. What I mean by that is here. If I take 4, let's try this one more time, and I raise it to the third, I get 64. So that means that 4 is a third root of 64. Is how we can read that. So we can write this in this notation here. 4 is the third root of 64. So notice how I'm using that same radical that we've used before, except now I'm writing it with a different number out here. And this number right in there, that's called the index. So the index tells you what root you're taking, which is really important when we're talking about roots and radicals. Okay, so let's make some connections here between radical form and exponent form. As you see here, we have the square root of a. That's the same thing as writing a to the 1/2. Here's how we get there. A is really being raised to the 1 power. Right? We don't normally write that, but it really is there. And what's not written when we talk about square rooting is the index is understood to be 2. So hopefully you can see where we're getting this a to the 1/2, right? We're taking the exponent that's inside the radical as our numerator, and our index is our denominator. So we can expand this out for other expressions as well, like the cube root of a to the 1. That's really a to the 1/3. This also works if we're doing, let's say, the 4th root of b to the 3rd. Can you guess what this is going to be? Well, this is going to be b to the 3/4. And here's one more for us. I'll use a different letter, maybe c. Well, the square root of c to the 5th. Well, remember, if your index is not written, it's understood to be a 2. So I can change this to c to the 5/2. So we'll see the fractional exponents or rational exponents a little later on in this lesson here. For now, I'm going to stick with the whole numbers. So we're going to look at some connections here between real nth roots and what happens with the number of solutions that we get, and what kind of solutions do we get when our index is odd or when our index is even, or in this last scenario we're going to look at what happens when the number on the inside of the radical is negative. Well, most of this is actually old stuff, but we really haven't seen the fact that we can take a cube root or a 5th root or a root number that's odd. So something like if we took the cube roots of 64, well, I have to think about that for a second. I'm trying to think of a number that when I multiply it by itself or use it as itself as a factor 3 times, I get 64. And with a little bit of thinking, you can come up with the idea that 4 times 4 times 4 equals 64. But there's no other number that does this, right? It doesn't work with -4. -4 times -4 times -4 doesn't equal 64. It equals -64. So the idea here then, I'm looking back at this line, if n is odd, we're going to get one solution. And it's just going to be whatever the nth root of our value is. In our second scenario, we've actually seen this quite a bit with quadratics. We often get two solutions, right? We get plus or minus the square root of a number. If we start off with something like x squared equals 36, we know that we get x equals plus or minus 6. So we can get two solutions if our degree is even. If our index is even. So that's actually the case for all, every time our index is an even number. So we get two solutions, and we say that we get plus or minus the nth root of a. Okay, in our last scenario here, I'm going to say n is even. In other words, I'm taking something like the fourth root or maybe the square root of something, and inside is a negative value, like negative 32. Well, there's no number that when I multiply it by itself 4 times, right? This is some number times itself 4 times, and I'm getting a negative value in here, right? Well, if it's a negative times a negative times a negative times a negative, I'm going to get a positive number, right? So this is going to give me no real solutions here. We might get imaginary solutions. In fact, we will. But that's beyond the scope of this course right now. Okay, so then let's actually do a little practice here with taking different roots of different numbers. So for our first example here, the way to read this is we're taking the third root of negative 125. So the first question is, can we even do that? Can I take the third root of a negative value? Well, yeah, with odd number roots, we can always take that root, right? Even if it's negative on the inside. So that's not a problem here. The question is, what number, when I multiply by itself 3 times, gives me negative 125? Well, you might not know this right offhand. You might need to do it, kind of work backwards at this. If we take 2 times 2 times 2, does that equal 125? Well, no, that's 8. That's not even close, right? So you might want to then figure out, well, what's 3 times 3 times 3? Does that work? What about 4 cubed? Eventually, you'll hopefully come to the idea that 5 cubed gives us 125, but that's not what this problem is saying. This is saying find the cube root of negative 125. So maybe it's something as simple as making that a negative 5 cubed. Well, I'm going to check this and make sure that this works. So does negative 5 times negative 5 times negative 5, does that equal negative 125? So let's check out what's happening with all these negatives. Well, there's an odd number of negatives, so I can cancel the first pair of negatives, and I'm left with this other negative there. Okay, so far so good, because that's what I have here, right? And then I have 5 times 5 times 5, and indeed that is 125. So yeah, there's my check. Negative 5 times negative 5 times negative 5, or negative 5 cubed is negative 125. So it looks like I found the third root, or the cube root, of negative 125. Okay, moving on to the second problem here. We're going to find the fourth root of 16. So remember, we're going to get 2 solutions here. We have an even root, an even index, and the number on the inside, which by the way is called the argument, is positive. So we're going to get 2 solutions here. We're going to end up with a plus or minus of something. And you just need to kind of go through your list and say, okay, what number times itself 4 times is going to give me 16? Well, hopefully you come across the idea that 2 times itself 4 times, or 2 times 2 times 2 times 2, is going to be 16. Likewise, with negative 2 times negative 2 times negative 2 times negative 2, is going to give us positive 16 as well. So I'm getting 2 real fourth roots of 16. Okay, now to some a little more fun stuff here, a little more of a challenge. What's neat about exponents is they don't need to be whole numbers. We saw this back on the first or second slide there, where our exponents weren't necessarily whole numbers, right? We had like 3/4 or 5/3. So it can be other stuff like we can raise numbers to the 3/2, or we can raise a number to the -4/5. Those are perfectly acceptable. We call those rational exponents because they're a ratio, right? They're a fraction. Okay, so let's do a little evaluating here. We're going to evaluate 9 to the 3/2. So what I'm not going to do, what I'm absolutely not going to do, is think of this as 9 to the 1.5. That is of no help to me whatsoever. I want to keep this as a fraction, because that fraction means something to me, right? That's really, I can write this in radical form, and it's going to have a different meaning for me. So what I can do is I can write this as, well, get timing there, the square root of 9, and then I'm going to cube it. I can write it like that. Or I can also write it as 9 cubed and then square root it. So my question for you folks is this. Do you know what the square root of 9 is? Well, hopefully you do. Can you take that number and then cube it? Hopefully you can. This first one here, this first method that I'm showing you, is probably the preferred method of doing this. Do you know what 9 cubed is? I certainly don't. You might. I don't. And then after you get that, do you then want to square root it? So you probably don't want to do the second method. So my suggestion here is this. Go small before you go big. In other words, take the root first, make it smaller, and then raise it to the power and make the number bigger. Because that's the way that this one's going to turn out anyways. So I'm going to take this first method that I suggested here. I'm going to take the square root of 9 is 3, and now I have 3 cubed, and I can do 3 times 3 times 3, and I can get 27. So I can say that 9 to the 3/2 is 27. And if you're not sure about that, if you ever get caught up in these and you're not sure, did I do this right, there's a couple things you can think about here. First of all, I'm raising 9 to the power of something that is more than 1. So you should expect to get a number that's more than 9. Okay, well 27 is more than 9. Sounds great so far. You can also just put this right in your calculator if it's available. Not that you can always do that on a quiz. But you can put that in your calculator and you should get back 27. Okay, let's do one more of these. Let's do 32 to the -2/5. So the first thing I'm going to do is I'm going to rewrite this so that it's the 5th root of 32, and then I'm going to raise that to the -2. So don't freak out that we have a negative exponent here. We're going to deal with the negative really at the end. I'm just going to do all my other stuff first. So my first task is to think, okay, well, what number multiplied by itself 5 times is going to give me 32? Well, as it turns out, 2 to the 5th gives us 32. So the 5th root of 32 is going to be 2, and now that's raised to the -2 power. Well, this is no longer really a tough problem, now is it? Because now what I can do is I can say, well, 2 to the 2 power, that's 4. But my exponent is negative, so that means do the reciprocal, right? So instead of writing 4, I'm actually going to write 1 over 4. So as a check here, again, what I'm going to do is I'm going to go back to my original problem here, and I see that 32 is being raised to a fractional exponent to the 2/5 that's less than 1. I'm going to expect to get a number that's less than 32, and then because of the negative, I'm then going to take the reciprocal of that number. So yes, the 32 to the 2/5 would be 4, but then it's a -2/5, so I'm going to flip that, and I'm going to get a quarter. Okay, so let's formalize what we have with our rational exponents. So if I have a base to a rational exponent, a to the m over n, we can rewrite that in radical form by putting the numerator inside the radical, so a to the m, and taking the nth root. So this would be making a larger and then smaller. That's fine. We can also do this as the nth root of a, and then take that and raise it to the nth power. Both of those work fine. Again, my suggestion is the second one here where you make your number smaller and then larger is probably the way to go if you're evaluating it. Likewise, with our second scenario here, really our answer is going to be about the same thing, but we have this negative exponent. So I'm really going to have 1 over the nth root of a to the m. Or I can write this as 1 over the nth root of a, and then raise it to the mth power. Both of those work just fine. Okay, let's breathe for a second. We go on one last topic, and then we'll be done with this video here. So we're going to unwrap this equation, and we might even use the calculator along the way here. But really, we don't need a calculator to help us out with this, because really what I want you to do is just to be able to unwrap this. So if we look at our equation here, we're doing x plus 5 to the third, and that equals 17. Well, if we think about unwrapping this, what can we do here to unwrap this side? Well, the whole thing is being raised to the third power, so I really could take the cube root of both sides. So I can take the cube roots of both sides like that. Okay, well, that is going to leave me with x plus 5 on one side, and on the other side I'm going to have the cube root of 17. I have no idea what the cube root of 17 is. I could probably estimate it, get a decimal answer, but really I'm just going to leave it just like that, because my goal here really is just to get x by itself. So the last thing I'm going to do here is subtract 5 from both sides, and we get this rather unusual looking answer. And again, we could get a decimal here. But I'm really just going to leave it as the cube root of 17 and subtract 5 after that. I've isolated x, I've got it by itself. I've unwrapped this equation here. Okay, so what we're going to do to make a connection to our calculator use here is I'm actually going to put this expression in my calculator, so I'm going to get a decimal answer here. So here's how we do this. So let me just bring up my calculator here. And remember, I want to do the cube root of 17 in my calculator. So I'm going to hit the math button, which is, we've done this before, right? It's over here on the left side. So I'm going to push that button. And we've used it for changing to fraction form. But what I'm going to use it for is number 4 here, which is the cube root. See how it's got the little index 3 out here? And then it has the radical. So I'm going to do that. Because it's a cube rooting is kind of special in that we do it often enough. There's a whole button for it. If we want to do the 4th root or 5th root or anything else, we're going to have to use number 5, which we can do later on in class. But I'm going to choose number 4. And you can see it has the index out there of 3. So I'm going to do the cube root of 17. And if you have a TI-83, what's going to happen is you're going to have a radical, and then it's going to have a parentheses, possibly. You're going to need to close the parentheses before you put in that minus 5. What I need to do is I need to push to the right, and now if you notice, this radical bar is no longer there. And now I can do minus 5. So then you're just going to do the cube root of 17, and then it's going to subtract 5, and I get an approximate answer of negative 2.4. So anyways, that's a rather long introduction to radicals. I hope you found it useful, and I look forward to discussing this with you when you guys come into class. Have a good day. Take care.